Welcome to Study Loop.
All right, now we're looking at question 24 in chapter 22. We just need to balance a few chemical reactions. And most of that is going to come down to just paying attention to mass balance, just using the information that we're given. For example, our first question here is going to be aluminum metal reacting with acids to form hydrogen gas. So let's take a look at that one first. So we're going to start with our aluminum metal. That's a solid aluminum. For those of you with legible handwriting, there we go. It's going to react with acids, and in our case, that's always going to mean some form of H+. That's going to form hydrogen gas. And in order to form hydrogen gas, we're going to have to take. So this is the skeleton of the reaction that we're given the information for. But there are some things we can infer from this. For one, that H2 gas, we can see that this hydrogen, this H+, goes from the +1 oxidation state to 0. So hydrogen is reduced. In order for this reduction to occur, aluminum has to be oxidized. So there's going to be some aluminum ions in the product. And aluminum forms 3+ ions. So that's going to be our other product. So we have aluminum solid plus H+ goes to hydrogen gas and aluminum 3+. At this point, it's just a matter of charge balance. In order to get all of these charge balanced, we need to make sure that the charge on the left is equal to the charge on the right. So to do that off the bat, you would say that we need 3 H+. But if we do that, then the hydrogen is no longer balanced. So if we multiply this by 2, we end up with 2 aluminum plus 6 H+. Goes to 3H2 plus 2Al3+. You see that we've got a +6 charge on the left, +6 charge on the right. We also have 6 hydrogens on the left, 6 on the right, 2 aluminums on the left, and 2 aluminums on the right. So this reaction is balanced. And we did that by saying that this aluminum needed to be oxidized in order for this hydrogen to be reduced. So we included Al3+ on the right side. And then we just multiplied the coefficients until we were able to have mass balance on the left and the right. Going back to our list, we've got our next question is steam reacting with magnesium metal to give magnesium oxide and hydrogen. So we've got steam, that's just going to be H2O gas, plus magnesium metal. It's going to give us magnesium oxide. And because magnesium forms +1 ions, and oxygen is generally in the -2 oxidation state, magnesium oxide is going to look like this, and hydrogen gas. So looking at the mass balance again, we're going to want to balance these magnesiums first. So let's put a 2 here. So now we've got 2 magnesiums on the left, 2 magnesiums on the right, 2 hydrogens on the left, 2 hydrogens on the right, and 1 oxygen on the left and 1 oxygen on the right. So actually that was pretty straightforward. This one's already balanced. We just had to multiply the magnesium coefficient by 2. And we had to know the oxidation states of magnesium and oxygen in order to know what magnesium oxide looks like chemically, what the formula looks like for that one. Alrighty. So next on the list, we have manganese oxide being reduced to manganese 2 oxide by hydrogen gas. So we've got manganese 4 oxide. So manganese 4 oxide means it has a charge of +4. So that means we have Mn, and it's +4. So that'll be O2 plus hydrogen gas. And we're going to get manganese 2 oxide out of this. So that'll be manganese. So that'll be manganese 2 oxide, which is +2 oxidation state. So, and then an oxidized form of water. Well, an oxidized form of water. Oh, that gives away the answer. An oxidized form of hydrogen would just be water. So for this reaction, we've got manganese 4 oxide, MnO2, plus hydrogen gas. And then on the right side, we're going to have our oxidized form of water, because the oxidized form of hydrogen, this is H plus when it's in H2O. And we're going to have our reduced manganese. And if we look at the mass balance, we actually see that we have 2 oxygens on the right, 2 on the left, 2 hydrogens on the right, 2 on the left, and 2 manganese on the right, 1 manganese on the right and 1 on the left. So we just had to be able to identify what the oxidized form of hydrogen was going to be in order to balance this reaction. So this is sort of the key component for this one. And then lastly, we have calcium hydride. Oops. Reacting with water. Calcium hydride reacts with water to form hydrogen gas. So we're going to start with calcium hydride. So that means that it's hydride, which means we have H minus 1. And it's calcium, which will be in the +2 oxidation state. So that means our formula is going to look like this. And it'll react with water. So that's H2O. And we're going to get hydrogen gas and some calcium byproduct out. This is very analogous to the equation 22.15 in this chapter as well. But we've got calcium hydride reacting with water to form hydrogen gas. And so What we would expect to see here then is that this hydride, or we're going to see some form of water being oxidized from -1 up to the 0 oxidation state. So we've got a hydride right now, so the H is in a -1 oxidation state, and here it's in a 0 oxidation state. So what we're going to want to do is we need to take this from -1 to 0 or +1. And so what that's going to look like is as a hydroxide. So that we can still have calcium ions with a counter ion, but we still have our hydrogen in the +1 oxidation state. So at this point, it's just a matter of mass balancing everything. So we see that we have 2 oxygens on the right and 1 on the left. So we're going to need to multiply this by 2. Then we have 6 hydrogens on the left and 4 on the right. So we'll need to add an additional additional hydrogen gas. And there we have it. There's the balanced reaction for this one. Because we have 1 calcium on the left, 1 on the right, 6 hydrogens on the left, 6 on the right, 2 oxygens on the left, and 2 on the right. So that's our balanced reaction for this one. Okay, so we had 4 different reactions that were also analogous to reactions spread throughout the chapter. Aluminum metal reacting with acids, so we had aluminum solid and then some H+ ions, which would form a hydrogen gas, and then it does that by having those H+ ions remove electrons or oxidize the aluminum. And when we balance that, this is the reaction we arrived at. And then our second example was steam reacting with magnesium metal. And once again, we had the water, which is in the +1 oxidation state, getting reduced and oxidizing the metal to give us this reaction. In our third example, we have manganese 4 oxide being reduced by hydrogen gas to form manganese 2 oxide. And then in the last one, we had calcium hydride, wherein the hydride was being oxidized by water to form hydrogen gas. I hope that was helpful.